Okay, it's a continuation video of previous one, sampling. So we already saw, so there are two steps to converting analog to digital, sampling and quantization. So sampling is a process, how it will be defined. Sampling is a process of measuring the instantaneous values of continuous time ticker in a discrete form. So that is called as sampling. So sampling is a process with measuring the instantaneous value of continuous time signal in a discrete form. So what is sample? Sample is a piece of data taken from the whole data in a continuous time domain. So it should be a piece of data, get it from whole data. So there is a sample. So in there, you have to convert analog to digital. So if you want to converting analog to digital, that means the value might be only is high or low. Means 0 or 1. So that is discretized in time. So the analog signal, that means high or low signal has to be discretized in time. This discretization of analog signal we can call as a sample. So continuous time signal x and t, the sampled signal we can call as a x, s and t. So it's an unary signal we can call as x comma t. T is time period and signal x. For a sample signal we can represented as x s t. When x comma t is multiplied by a period of impulse train, sampled signal x s and t. So see, this is a continuous time signal. This is sampled signal. So continuous time signal is look like a random signal and sampled signal. So based on the piece of data taking from the whole that waveform. So based on the fixed time interval, they're taking the sample. Then finally they sketch, and you will be to get the graph sampled signal. Okay, what is sampling rate? What is sampling rate? To discretize the signal, the gap, the signal should be fixed. The gap can be termed as a sampling period TS. I just now I said that means so how much of samples taken within the time period, that is called as sampling period or sampling time. So that is denoted as TS. And sampling frequency T by 1 by Ts. The basic formula frequency is 1 by T. So sampling frequency here, we just add the add as sampling. So sampling frequency Fs is equal to 1 by Ts, where Ts is a sampling time, F is sampling frequency. So sampling frequency is the reciprocal of sampling period. The sampling frequency can be simplified, we can call as sampling rate. I already said what is sampling rate. The sampling rate is nothing but so number of samples taken per second. or for a finite set of values. This is called sampling rate. For an analog signal to be reconstructed from digital signal, the sampling rate should be highly considered. So if you want to analog signal to be reconstructed from digitized signal, the sampling rate should be highly considered. So you know that the rate of the sampling, the message signal should neither be lost or not. That means it should be get overlapped when the rate might be it was fixed. So actually the Nyquist rate. So we have to avoid that overlapping. So we have to use Nyquist rate equation. So what is Nyquist rate? So with we consider W. W is the highest frequency. So the effective reproduction of the original signal sampling rate should be twice the highest frequency. So that is called as Nyquist rate. The Fs is equal to twice the highest frequency. The highest frequency we can say here W. So Fs is sampling rate. W is highest frequency. The rate of sampling is called Nyquist rate. So the message signal should neither be lost or not, it should get overlapped. Hence the rate was fixed. So that is we are using Nyquist rate. The Nyquist rate equation is Fs is equal to 2W. So W is highest frequency. So now we are going to see about sampling theorem. So sampling theorem, that we will see in another video.